Okay, eh, everyone, I'm Ajay Rawat. So I'm currently pursuing BTech in electrical engineering from BTCAT in Uttarakhand. My technical skills are mostly in programming languages like C, C++, and Python. But currently I'm moving into responsive web designing and IoT. So I built various projects and during this Bolt IoT internship. Uh, my major project is LER activated IoT based secure face secure recognition security system. So in this session, I'll be giving you a brief overview that what we are going to do and what are the problem we face that we needed to build this project. Next, we'll be going through the project objective, then the project requirement, and how face recognition is actually working. And that we will understand that how it is internally working. And at last, we will be setting up our device that to build such system. Okay, Rajesh, can you please move to the next slide? Yeah, so we know that digitalization is taking a whole new turn nowadays. Is we are having various great technologies like electric vehicles. From the time we used to build various machines, now we are teaching machines that how they can teach themselves by using machine learning and various neural network neural networks. So, but still in our doors and safe locks, we are using that old mechanical based locks. So my main idea behind this project was this only that I need to implement the biometric scanning system in our doors. Uh, and to build that system, you do not need much of a machine learning knowledge. I'll be giving you the code, and I'll be explaining you that how it is internally working. But we will not be going in deep into the machine learning part. Uh, okay, Rajesh, can you please move to the next slide? Uh, so, oh, so why do we need to? Why we got to build a face recognition security system? Even when we had mechanical base, so there were various problems. Like you remember a time that you forgot your cookies, you had to break your lock, and you have some load to carry, and you have to just put your load aside, then you have to unlock your doors. So it's a whole burden for us using mechanical based locks. So that's why I've built the face recognition security system project, so that it will be less time consuming. uh, contact it will be a contactless contact, and we do not need any physical keys. Okay, next slide. Okay. So in this session, we'll be learning that how we can build a prototype of a face recognition security system, and how we can activate that our project contactless, and we will also be understanding that how it is practically and conceptually working. In so next slide. Project requirement. So what all you will be needing? So you will be needing an LER. uh, if you are pursuing a Bolt IoT internship, so you may already be having all of these contents like LDR, LED, buzzer, Bolt IoT module. It was all available inside the kit. And you may be having a laptop, obviously, and uh, so you need to install Python in it. So before moving into the coding part, let's see that how the face recognition system will be actually working. Rajesh, can you move to the next slide? Yeah. So face recognition. You know that in Facebook we have face recognition system. If you have uploaded any photo, and it will be detecting that who that where the face is. And Facebook has all, it also has an algorithm which can suggest you to add someone to your friend list. How it all is working. All these companies like Facebook and Google, they all use machine learning algorithm. And in this project, I'll be using the Hawk CNN algorithm. Hawk is nothing but a histogram of gradient convolution neural network. Just forget about Hawk for a minute, and just see that how face recognition will be working. You are standing in front of your camera. In during 1980s, what the face recognition system used to do was to calculate the distances between our various face part. Like it will be calculating the distance between in our eyes, the distance between eyes and nose, the distance between eyes and mouth, and based on those distances, it will be detecting whether the person is an authorized person or not. But during the by advancement in technology, we got to the Hawk-CNN algorithm. Hawk-CNN. Next slide, please. Okay. What our face recognition library will be doing here is it will be taking an image and it will convert that image into a black and white image. Now you will be seeing that why do we need to convert an image into a black and white image? We need to convert that image into a black and white image because we do not need colors to detect faces. We can detect the faces without colors, and it will be much easier for us to find to recognize faces in black and white images. So first we will be converting that our the image taken by the webcam to a black and white image, and then the image will be pixelated. It will be converted into a 16 by 16 pixel. And uh, next slide, please. Uh, so here, here as you can see, there are various pixels in this image, and you may be finding that there are many pixels which are darker in comparison to others. We'll be if, for every pixel we will be checking whether its surrounding pixels are lighter or darker, and we will be making an arrow from lighter to darker. Can you please guide me, sir, to denoise the image using recurrent neural network? No, actually, I don't know about I haven't used a recurrent neural network. We are using the CNN model here. Uh, okay, Aftab. Uh, okay. Anyway. So now here what we will be doing that we will be creating gradients from lighter to darker pixels, and that arrows will be helping us to recognize faces. So we will remove all the pixels from our image, and we'll be keeping only the arrows there, and then those arrow will help us to determine whether the face is an authorized person or not. So, do you have any idea regarding V2X communication IoT? No, no, Rose. I don't have any idea about V2X communication IoT. Eh, so, Rajesh, can you move to the next slide? Yeah. I said that we need to create gradients. What are gradients? Just some arrow from pointing from the lighter pixels to the darker pixels. Now, why do we need to create gradients? Because if we just analyze each pixel directly, then the really dark images and really light images of the same person will have totally eight different pixel values. But by only considering the direction, that brightness changes. Both really dark images and really bright images will end up with the same exact representation. That makes the problem a lot easier. What does it mean? It means that if we just keep our pixel as it is, then what will be happening that if we have all the lighter pixels in our image, all the lighter pixels, then all those pixels will be having the same value. So we won't be able to recognize the faces here. That's why we need to create gradients, which uh, gradient, so that we can find that what are the basic structure of what is the basic structure of any face. So next slide. Yeah. So as I said that we will be creating a 16 by 16 pixel, and you can see that the face which was shown in the previous slides, that faces pixels are being converted into an Hawk CNN image. Hawk CNN is histogram of a gradient convolution neural network image. Here we can see that there are arrows, arrows which are pointing from the lighter pixel to the darker pixel, uh, and we have just kept only those pixels which have a major difference. Means if we have a pixel pointing from a lighter to a bit darker pixel, so we won't be considering that gradient. We'll be only considering the pixel which have a major difference and between two pixels. That is, it will be pointing from a lighter to a darker, and their colors should be much different to each other. So we'll be just filtering out the extra gradients from our image. Uh, so you do not need to, as I previously said, that you do not need to. Okay, you can get the slides at the end of this session. I'll be sharing you the slides. Yeah. So as I said previously, that you do not need understand the face recognition. I am just telling you these about these, that so that it can clear out your basic, and you can conceptually learn that how face recognition is actually working. Okay. All these information, we are using the face recognition library in Python, which will be itself doing all this work. You won't be doing all any of these work. Our library will be itself doing all these work. Okay. So here is our Hoxian image. Next slide. Now, uh, now we have converted an image into an Hoxian image. But don't you think that there will be some problem if the face is bit tilted? Yeah. We will be facing problems. Our system will be facing problems if the face is tilted. Now, what we need to do for solving this kind of scenario is that we need to create. We will be using a face estimation landmark recognition technique. And what our face estimation technique will be doing here is that. Is this session is recording? Yes. Okay. So what our face estimation technique will be doing? Can you move to the next slide? Next slide. Yeah. Uh, Okay, face landmark estimation technique. So what we are doing here is that we are creating 68 points, all our point in all the boundaries of our faces, like in eyes, surrounding our eyes, our face boundaries, our nose, our lips, and we will be creating a total 68 points there. And if the system find that the line from the nose is not in there in the center, it will be aligning in that image in such a way that now that image looks symmetrical. Okay, you are understanding that the image should look symmetrical in order to recognize the face. So we'll be using the face landmark estimation technique here. Next slide. So here we can see that in the first image, the face was tilted. The our system find the 68 points around it in the second image, and in the third image, you can see that the face is centered. The face is perfectly centered by measuring the distances between the nose to the left side of our face, and from the nose to the right side of our face. Okay. And then our system will be aligning that image so that our face recognition system could work. Next slide. Okay. So, oh, After creating so what our face landmark estimation technique is now doing is we will be creating 68 points, and after that 128 measurements will be done. What those 128 measurement will be will be, they will be the distances between two pixels, okay, our total of 68 points will be understanding that how it will be recognizing in next few slides. Next slide. Rajesh, can you move to the next slide, please? Yeah. So, we learned that how our face recognition technique is creating face estimation points, and how it can uh, it is working, how it is recognizing the faces. Now we need to find that how. Please repeat previous point. Okay, what I said in previous point is that uh, we have an image. We have that image. We will be converting that particular image into a black and white image, and after converting that image into a black and white image, we will be pointing creating gradients. And those creating gradient will be pointing from the lighter pixel to the darker pixel, and after creating gradients we are still facing one issue. What issue? We were facing the issue that what if the face is tilted. So for solving that issue we were using the face estimation face landmark estimation technique. And what it was doing, that it was aligning our face. It was just aligning our face, and after aligning, why not dark to lighter? It's just a choice. It's your choice. It actually doesn't matter from darker to light, or lighter to darker. Okay, Sivesh, it doesn't matter. It just we have two choices. We want uh, we prefer the first choice. There's no problem that if you want to move from the darker to lighter pixel. Okay. Yeah. Uh, Now, what we were doing in the triplet previous slide, please. Yeah. So I was saying that how we are recognizing faces. So the face recognition technique work in such a way that when your webcam is on, it will be scanning our faces. It will capture an image of our face, and from the images which are already in the system as an authorized personals, and all and an unknown image. So three images will be going through our systems, will be going through the face estimation system, and the face still 128 measurement will be created. And if the image captured found have 128 measurement, same as the 128 measurement of an authorized person, then we will say that yes, this is the authorized person. Otherwise we will say that it is an the person is an unauthorized person. Okay, so that's how our triplet training is working. We will be having the first image will be the image captured through webcam, and the second image will be in the image which we already have in our system as an authorized person, and the third image will be an unknown image of an unknown person. Okay, so then we'll be checking whether the person is authorized person or not. Okay, next slide, please. Yeah. Along with the so when we are storing when we are storing the face estimation points of 128 measurements of any authorized person in our system, we will be also saving his name, his or her name, so that we can point out that which person is which one. So finding the person name is working in the same manner, that it will be checking in the database that the test image measurement are similar to which authorized person image. That's how it will be getting the person name. Next slide, please. Yeah. So that's all how the face recognition system was working till now. Uh, Again, I am saying that you do not need to worry that how it is working if you do not understand. I'll be sharing a YouTube link and link to my article and also this slide with you all guys so that you can learn up from it later. So here, what we are having is we are having an IoT module, Bolt IoT module, and we are having a buzzer. We are having an LDR, an LED, and this register. You can just ignore this register if you do not know. This register is actually. Can you demonstrate the project? Okay. By the way, yeah, you know that I'm facing some technical issues. In internet connectivities. Otherwise, I would have uh, shared my project with you all guys. You can if you want to learn about this, you can. I'll be sharing the link. Okay. So Rajesh, can you play that video, please? Uh, so if you guys want to get a brief summary of this project, then you can view this video. Uh, I've properly explained everything that how the face recognition is working. It is a small video. It is not a lengthy video. So we will be jumping into the project session only. Uh, Rajesh, can you please move to the 4 minute? Uh, 4 minute. Yeah. Please pause. Can you pause the screen at 350 3:15:07? Uh, yeah. So here you can get a brief summary that how our project was working. And the image is converted into black and white image, Fox CNN method applied, face landmark estimation method applied. Then triplet training is done, and that's how we will be getting in and the authorized person face. Now, can you start a video, please, Rajesh? Can you pause? No, actually, you can. Uh, Sivesh, if you have any doubt, you can ask during the Q&A session. Okay, move ahead, Rajesh. So here, you can see that I've put my finger. Oh, can you pause the video? Yeah. So here you can see this is my hardware setup here, uh, in the right hand corner, and you can see that there is an LDR. So why I added an LDR to my project? So you know that if I just kept my system online for a very long time, then you know that you will be having power as well as memory loss. So I have added an LDR which will be saving power as well as it will be saving memory. So LDR is helping a lot in this project, and that's why it is named as LDR activated. So when I'm putting my finger over the LDR, the LDR is giving signal to the bolt, is giving information to the bolt IoT device, and that bolt IoT device is sending that information to the bolt cloud, and from that bolt cloud we are fetching that information through API to our Python code. Okay, so that's how our information is being transferred, and that inform our Python code is extracting that information and checking whether the light intensity is changing or not, or and if the light intensity changing, it is turning our camera on, and checking whether whether there is an authorized person in the camera vicinity and viewing angle or not. And if you are not in this video, you may not find my face, but uh, when I put my I was in front of my screen when I put my finger over this LDR, so it found my face. And if the face is found, can you play the video? uh, okay. Can you pause it? Can you move back again to 412? 4 minute and about uh, 12 seconds. Uh, Here, so 4 minute 12 seconds. If Rajesh, if you could move to 4 minute 12 seconds, would be great. Otherwise, I could explain it orally also. Yeah. Uh, Play the videos. Please pause it now. Please. Okay, so here you can see that when the camera found my face, when the camera found my face, the LED turned on. You can see the LED there in the circuit, and here I have added an LDR because this was just a prototype. Actually, the my main motive behind this behind creating this project was to create a prototype actually. But if you want to make a proper system which could unlock your which could unlock your device. So you can add a relay to relay instead of this LED, and to that LED relay you can add a stepper motor which will be acting as pulley and pulling up the lock in order to unlock the door. Okay, yes, I guess I hope you are all are understanding. Mm. Okay, I will be explaining the face recognition part later in this video, but just move ahead. Actually, the time is limited and we lost some time in the beginning. Okay. Eh, yeah. Can you turn on the audio, please? Actually, when the face didn't get recognized, our buzzer start ringing. So that the person can be. Okay, I'll be sharing the code, but just first see the project here. Rajesh,
So 1 minute
if
I will reshare it again so that you can open the audio. Okay.
yeah. Hardware configuration. So you said okay.
Is that okay?
Actually, Rajesh, audio wasn't audible.
Audio is not audible. Okay.
Actually, if you guys can check out the video yourself.
It's centered using common tools. Now, for
Can you
recognizing,
jump
triplet
to
training technique is used,
jump to
where 3
minutes.
images are used. Prototype that we built. Here, as I run recognition.py file, our program will start receiving signals from Bolt Cloud. And as I put my finger over LDR, the light intensity decreases, and our face recognition system starts. Then, if program detects authorized personals and camera viewing angle, it will send signals to turn the LED on. And if there is an unknown person, it will send signals to turn on the buzzer. Also, it will send telegram message to the authorized persons for every login, and intruder alert if intruder is detected.
Okay, that's all. Can you pause the screen?
Thank you for watching.
Yeah. So here you can see that when the page didn't isn't an or recognized person, when the person is not an authorized person, the buzzer will start ringing for 10 seconds, and for every login, we will be getting a Telegram message as well. Even if it is an authorized person, if it is an authorized person, the our Python code will be sending the name as well as the time at which the person got access and if the person is not an authorized person, it will send an into the alert to and Telegram message as well as it will start ringing the buzzer. Okay, so that's all. That's all. That is all happening in this project. Now let me share the screen, the coding part with you. Wait. I'll be sharing the Python code if my connectivity, if my connection is working on. Actually, the code isn't there in my presentation. The code need to be shared externally by myself. Uh, okay. So I'll be sharing my screen. Tell me if it is visible on. What is Rajesh? Can you please allow screen sharing?
Now try again.
Okay. It is still showing host disabled attendee screen sharing. Yeah. Yeah. Thank you. Thank you, Rajesh. Is it visible? My screen is visible now.
Yes, you can go ahead.
Okay. So here you can see this my Python code. So this is a recognition .py file. So it is getting information. It is importing various libraries here. The libraries are face recognition library, the CV2 library, NumPy library, pickle library, pickle request time, JSON, conf, bolt IT, and all. So we'll be talking about this library later because each function is associated with this library. So here first of all what we do is we create a embedding file. So yeah, this is my embedding file. So you can see that in this we have imported various libraries. The face recognition library is the most important library here because all the work which I told you that how the CNN model is working and how it all is working. So it all is included in this face recognition library. Okay, that's why I said that you do not need to understand in detail about this topic. Okay. So first of all, we will be getting the name of the person, and a reference ID is an optional ID. Is an ID which, if the person can give any number, and then our program will try opening the reference and the pickle file. The pickle file will be containing the face estimation, the 128 measurement which I told you about of the authorized persons, and what this embedding.py file is doing is that it will be creating our Python code. It will be creating 128 measurement. Here you can see that we have created a loop. Five images will be taken. Uh, if the person press S, if the person press S, you can see here in this part. If the person press S, the image will be captured, and the face recognition file, the information will be saved into the embed dictionary. Okay, so here to this dictionary, our 128 measurement will be saved. And if the person type Q, he or she can quit. So that's all about this embedding file. Now let's see about the recognition file. So recognition file. So here we can I've created various function here. You can see that these are the major function. The read function. Read function will be will be reading the data of the LDR. The buzz on the function will be reading the will be turning on our buzzer. It will be giving a high value when the function is called, and buzz off function is giving a low value to the to our bolt IoT cloud out zero port. You can see the port here, zero port, or to when the buzz off function will be called. And motor, actually the motor and the motor on and motor off are actually turning on and off our LED, because I told you that I haven't added the motor yet. So instead of instead of using this motor on and off, we'll be using the LED. Okay, so we'll be majorly using the LED only. Now this function will be helping us to send the information about the telegram to the telegram. Okay, now this is where our whole program is working. Our main face recognition function program is working. So first of all, you know that if you have noticed that both IoT cloud IoT module have some limitation, and the limitation in both IoT module is that for a time limit, not unless if you have a premium version, you won't be able to give enough API signals. Okay, so that's why I've added a time dot sleep function, so that I do not cross that limit. And if the value changes, if the LDR value changes, you can see that the function data function is the read function is called, and read function will be reading the LDR value. And if the LDR value changes by by at least 40, if the value changes by at least 40, the image will be captured. Okay, and if and the image will be captured. Okay, and you can see here in this part, we are opening the pickle file. This pickle file will be holding the 128 measurements. Here you can see the pickle file as well. These are the pickle file. Reference name will be holding the name of the authorized person, and embedding will be holding the name of the encodings of the authorized person. And we will be saving all that information in this face known face encoding and known face is name, these two list. Okay, so when our so as I was saying that when the image will be captured, that that image will be a frame will be created around that image. And 128 measurement will be calculated for that particular phase. And for every phase in the list of authorized persons, the phase our program will be checking whether the person is an authorized person or not. So if the face is by default set as unknown, so if the name still remain unknown, then we will say that yeah, the person is not an authorized person. And if the name changes to an authorized person, then we will say that yeah, the face is an or the person is an authorized person. Okay. So if there are matches, so you can see the if matches best match index. Okay, we will be giving the index of the best match. And um, if the face is found, the information will be given in form of telegram message. Here you can see the telegram send telegram message function is here, which will be taking a string value message, and and message string is holding is will be holding the name of the person. And a message will be sent, for example, Ajay is granted access at current time. Current time function uh, is a function inside this datetime library. So and for comparing the faces, we have this compare faces function available inside the face. So you can see that all the functions which are available inside the face recognition library are already there. Their name can already suggest you, as we know that Python is a very simple language. And the function is the library is created in such a way that it is easy to understand for everyone. You can see that it will create this function, this face encoding function will be creating the encodings, and face location will be creating the will be finding the location of face in any particular image. Okay. And if the intruder, if there is an intruder, a message will be sent that intruder alert, and the buzzer, and so here you can see the motor is turned on. Motor means LED. Here in this case, motor on means it will be turning on our LED for 2 seconds, and if the person is an unauthorized person, then we will be turning off the LED if it is on already, and will be turning on the buzzer for about 2 seconds. Here you can see the time limit. For 2 seconds, we'll be turning on the buzzer, and after that, we'll be giving instruction to the Bolt IoT cloud to turn off the buzzer by calling that buzzer function. You have already seen the buzzer functions here, which have and these all functions are already declared here, and that's all how our face recognition system was working.